Hello, and welcome to 5 Minute Math. Today we are looking at the seventh grade concept of simple and compound probabilities. This is standard 7.6i in the great state of Texas, and we are using item number 13 of the 2025 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we've got a box here, contains 5 colors. We've got red, orange, yellow, green, and blue. And then Caden is randomly selecting a keychain, records its color, so a random selection, recording its color. And then here's the key. It returns that keychain to the box. So once Caden returns that keychain to the box, our total stays the same. So that's going to be important for us because if the total did not stay the same, we would calculate this probability, which is what we're looking for, experimental probability. We're going to calculate that slightly differently. So total stays the same. And Caden did this 40 times. Here are our results. We're looking for the experimental probability that the next keychain will either be yellow or green. All right, so there's a way to visualize this. And so let's look at make this a little bit less transparent. I'm going to give you 7 reds. So 1, 2, 3, 4, 5, 6, 7. I'm going to get you 9 oranges. I don't really have an orange, so I'm going to call it purple. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to put that right here. It's just kind of as our picture here. We've got yellows. And so we don't really have yellow, so we'll go ahead and make that a black. So we're just having to kind of make our own colors, but we'll put that key there. 1, 2, 3, 4, 5. We've got 8 greens. Put that right there. 1, 2, 3, 4, 5, 6, 7, 8. And then we've got 11 blues. We do have blues. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so what do we have here? We have a total of 1, 2, 3, 4, 5 this way. We have a total of 1, 2, 3, 4, 5, 6, 7, 8. All right, so we have a total of 40 attempts. And we know that because we counted each dot, and it also tells us that total right there. But if we just add all these up, we're going to get 40. So we don't know how many actual reds are in there. It just says we've got 5 colors. We don't know whether there's an equal amount of red, orange, yellow, green, and blue. My guess is that you've got more blues than anything else because look, blues was chosen the most. My guess is you have less yellows than anything else, but we don't know because you only have 5. So we're not looking for theoretical probability. Theoretical probability is they tell you how many you have and how much should you have. Experimental probability is exactly this. Do the actual experiment, figure out how many times something pulled out, and then figure out what is the probability of that happening next time. So I'm looking for a yellow. So our yellow here is going to have to be, we don't have a yellow, so we're using black, and then that green. How many do we have? I've got this chunk right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, and we missed one right up there. 13. Because 8 and 5 make 13. So that's really what we're looking for. What are the probability of yellow or green? I've got 13 because that's really 8 plus 5. And then the probability can be shown as a ratio. A lot of times your probability is shown as a fraction, which you see here. And so we see 13, and then the question is 13 out of what? Well, how many total are there? Well, we did it out of 40 times, so we're going to just show it like this. So out of 40 different attempts, we pulled a yellow or green 13 times. So our experimental probability that the next time it will be yellow or green is going to be B, 13/40ths.